Welcome, everyone. Thanks for joining us today. It's noon, and we'll go ahead and get started with the webinar. We're glad you're able to make it today to discuss residential load calculations, the manual J, and more. So we'll discuss some of the steps that come after that. But our focus today will be on the manual J for sizing residential HVAC equipment. We're here as a preferred education provider for the ICC. So if you need continuing education credits, those will be available for participation, and also for the AIA. So if you need those credits, we'll be in touch after with the recording for the event and the slides, but also with information about getting your credits. So you'll hear from us if you need those credits. Our learning objectives for today are to understand when a manual J load calculation should be performed. So when is the load calculation required and applicable? Then next, we'll understand how to look up the information for a manual J. So essentially how to find and input the information to perform the calculation. And we'll cover some common mistakes made in manual J entries so that you can avoid those pitfalls when you do your own calculations. And finally, we'll understand how to use some of the software packages for detailed load calculations, which is the most common way most folks are going to perform these calculations. So before we jump into that, a bit about who we are. We are CDAC, the Smart Energy Design Assistance Center at University of Illinois, and our goal is to assist buildings and communities in achieving energy efficiency, saving money, and becoming more sustainable. Ultimately, all this is towards our goal of reducing the energy footprint of Illinois and beyond. We're here today as a partner with the Illinois EPA Office of Energy. So we want to thank them for their support, not only of this webinar today, but of our energy code training and technical services broadly. So thank you, IEPA State Office of Energy, for your support. And we want to quickly introduce some of our other resources if you're not aware of them. In addition to workshops and webinars, which we have always some coming up, we have online resources, and I'll put this website in the chat so you don't have to copy it down. And we have technical support. So if you have questions about energy code, please do email us energycode@illinois.edu or call the number. We love emails because then we can make you a complete response. But phone calls are always welcome too. We're happy to chat. And here's a little preview of some of our online resources. If I can, here we go. So here's that website again in the chat. And these are some of our other training and support services that are available online. Of course, our workshops and webinars, and that includes recordings of past events. But we also offer online courses, which can provide CEUs on demand. So if there's a topic that you need to brush up on, you can probably find it in our online courses, and you can get some continuing education credits for completing those courses. And of course, our technical support, as I already mentioned, please do reach out if you have questions. And we have a few other energy code resources, some frequently asked questions and information. And then this useful website down here is an easy way to access different resources you might need for code compliance. So we have links to the IECC, the Illinois amendments, and like the Chicago Energy Code. So you don't have to copy all these down, just go to our website and you can bookmark them from there. So with that introduction, we're going to jump into when to conduct a manual J load calculation. When is this load calculation appropriate and what does it do? So manual J is a document by the Air Conditioning Contractors of America that calculates heating and cooling peak loads. And the reason that we're often introduced to the manual J is that it's a requirement of the Energy Code. And it's a requirement of the Energy Code because it's critical to appropriately size HVAC units, both for their efficient operation, to provide dehumidification, because oversized units are going to short cycle, reducing efficiency, and also not running long enough to effectively dehumidify spaces often. And they also lead to increased comfort and proper operation of those systems. Proper sizing, as an added bonus, also avoids excessive upfront capital costs related to oversizing equipment when it's not needed. So it's an efficiency requirement through the energy codes, but also good practice for ensuring efficient operation and optimal comfort. And Manual J, as is noted here on the document cover, is for residential load calculations. So this is not for commercial buildings, and it's not for multifamily units that serve multiple apartments. So, Manual J is appropriate for a HVAC system serving a unit in like a small multi-unit structure. It's also appropriate for single-family detached homes, of course, condominiums, townhouses, manufactured homes. So this is for your residential load calculations. And Manual J, to give you an idea of how the manual is organized, there's two portions, normative and informative. So parts N, the normative requirements, and the normative tables contain the minimum requirements for conducting a residential load calculation. The informative parts, which are 1, 2, 3, and 5, contain additional explanation, details, and examples that clarify those normative requirements. So it's a pretty big document, but we're going to break it down for you today and explain how it works. Manual J has two versions. There's an abridged version, which is the Manual J speed sheet, which is available on their website, and we'll look at briefly here. And it's a limited set of default values for essentially pretty basic construction. So these are pretty strict rules, but it is a relatively quick and easy way to complete the Manual J. And it's good for early design. It's also good for getting a sense of the calculations and can be appropriate for replacing equipment. So, but there's a lot of key limitations to this abridged version. The abridged version requires that it's a single family home with less than 15% fenestration, which is relatively equally placed on all orientations of the building. It has to be single zone HVAC, no radiant heat. It must be a dark shingle roof, no encapsulated attic, so only a vented attic or a vaulted ceiling. Default appliance and occupancy loads, no engineered ventilation, and ducts must be sealed and insulated to an assumed level. Also, there's limited lookup tables based on these limitations, so there's not a lot of flexibility here. And these are just some of the key limitations that that I'm stating here. I'm not going to run through the whole list for you, but there is a checklist in the Manual J that will let you know if you're able to do an abridged version. Now, this might be appropriate for some replacement units. It's much more likely that if you're designing a new home, you're going to end up using the complete version, which uses full software. This is something which is almost never done by hand. It's really not designed to be done by hand. But it also provides a lot more design flexibility. It allows you to incorporate your blower door test results, and it accounts for more assembly types and installation practices. So abridged version, quick and easy, but very narrow, a lot of restrictions, and the complete version allows a lot of flexibility, but you need to use software. There's also two methods within those paths. You can either do a whole house method, which essentially takes the whole building into consideration together and finds the load for the whole building, or you can do a room by room load and add them together individually. The whole house block method is a little bit simpler. And if you're replacing equipment and not changing any ductwork, that could be appropriate. But the room by room load is going to be necessary generally for a new home, because you'll need those room by room load calculations for the Manual D, which we'll talk about a little more at the end in terms of next steps. But the Manual D enables you to size and design the ductwork. So if you're going to be designing ductwork, room by room load is the way. If the ductwork is remaining the same, the whole house block method is probably going to be appropriate in that case. So, oh, I'm sorry. The speed sheet, excuse me, here's an image of that Manual J speed sheet. So you remember we spoke about the abridged method on the one hand and then the full method. This is a screenshot of the abridged method. This is a free download of it. It's an Excel sheet from ACCA. So from the folks that publish the Manual J, they also publish this Manual J speed sheet, which automates the load calculations for that abridged calculation. And this is something that you can use to design those simple projects. You can see at the bottom, there's a bunch of different tabs, and you'd mostly be filling out the yellow tabs, and the green and that J1 form. And then this one that we see here is where a lot of the outputs come out, because the white blocks are where you fill in. This can be good for your simple projects or replacements, but is rarely going to be the right approach for a new construction project, if at all. But it's also interesting to see what's behind the software. So here's the Manual J speed sheet for that abridged, very limited option. And then here's some of the software availability for the full Manual J. This is not intended to be an exhaustive list, but here are some of the softwares that we find that folks commonly use. Also not intended to be an endorsement by any means. You can find the full ACCA Manual J approved software list on ACCA's website. And we'll talk a little bit more about these softwares and how they work towards the end of the webinar. For now, I think we're gonna complete this discussion of the introduction and pull up a quick poll question just to review a little bit about the purpose of Manual J. So what is the purpose of Manual J? Is it a method that ACCA uses to make money off of home builders? Is the Manual J used to calculate peak heating and cooling loads? Does Manual J ensure adequate airflow to every room in the house? Or does Manual J a means to verify code compliance, energy code compliance? And number two, if you're designing a single family home with a light colored roof, exhaust only ventilation, single zone HVAC, and no radiant heat and a vented attic, can you use that limited speed sheet? So those are the two questions. Thank you all for your inputs. And as you're filling this in, I'll mention I'm going to now pass it to Sean as we move forward. We'll talk about actually using that Manual J. All right, so we have pretty many responses coming in. So I'll go ahead and share the results. Now, this first one was pretty easy for folks. The Manual J is used to calculate peak heating and cooling loads to assist in proper sizing of equipment. The Manual J is used to size ductwork. So and we'll talk about this later. So the Manual J helps us to assure that adequate airflow, but that's actually the job of what's called the Manual D, the ductwork design. And then Manual J is part of your code compliance, but it doesn't actually verify code compliance through energy modeling. What it does is defines those heating and cooling loads so that you can properly size that equipment. But it's just one step towards energy code compliance. And then this next one is a tricky question, and that's why we wanted to put it here. If you're designing a single family home with this light colored roof, you're not going to be able to use the abridged version or the speed sheet, because it requires actually a dark colored roof. And the reason for that is that dark colored roof will increase the cooling loads because of the increased heating of the attic. So that's going to actually change your load from those default values. So you'll have to actually do a full Manual J. So that is a very narrow path. So that's something we wanted to point out, that you wouldn't be able to use that abridged version for even such a small difference. And with that, I will pass to Sean to share about using the Manual J, some of the steps involved in performing the calculation.
All right, thank you very much, Jane. Appreciate that. So as we go through using the Manual J here, we're going to be looking at portions of the speed sheet just because it's easier to reference those. And it gives you a good idea of what's going on in the background of a full software program if you're doing the full Manual J. So first thing we're going to look at here are what types of information do you need to start entering information into a Manual J. The first step is gathering your climate information. You need to know your design, outdoor heating and cooling temperatures, what kind of variation in temperature you have. So gathering that climate information is the first step, and it has an impact on almost every load calculation throughout the Manual J. So it's very important that that information is correct. The next step is what your design interior conditions are, what your design temperature is for heating and cooling, what your humidity level in the home is going to be, equipment loads and occupant loads. So having all that information pulled together. And then probably the most detailed step are the building details. What are your insulation levels? What are the surface areas of the building? Air infiltration rates, duct leakage rates, all that information. So most of this presentation is going to focus on that step 3, but probably step 1 is the most important part. Making sure that those temperatures for design are the correct design temperatures. And even step 2, those indoor design temperatures can have a big impact on the load calculations if they aren't properly selected. So what are we tracking in Manual J? The big things we're looking at are the energy lost and gained through the building. And the thing to kind of be aware of here is that it's slightly different conditions based on your summer peak loads and your winter heating loads. So in the winter time, when you're doing heating load calculations, you want kind of that worst case condition to determine what that peak load is. So in the winter time, that's at night. You don't have supplemental loads in the building, so it's an empty house essentially. But you've still got ventilation and infiltration coming into the building. So that's kind of your worst case heating condition. In the summer, it's almost the opposite. Peak heat of the day, you've got fully occupied building. They're running all the equipment at once on top of ventilation, solar gains through the windows. So you've got a lot more heat gains in the building that you're accounting for gains for cooling loads, and slightly fewer loads when you're calculating your heating loads as loss from the building, because you don't want to have a condition where you're accounting for things running in the building and generating heat, and then if those aren't there, now your equipment's undersized. You could have issues with the equipment not maintaining temperature in the home. So as I mentioned, that step 1, very important to find your climate data and get that correct. There are tables in the Manual J that contain this weather information. It is sourced from the 2013 ASHRAE Fundamentals weather data for the most part. There are some weather stations that come from other areas. But by and large, you're looking at the 2013 ASHRAE Fundamentals climate data as the source of these design weather conditions. There is a free link listed here on the slide to access that information through a free source. So if you don't have ready access to the Manual J itself, it's a good lookup reference for that information. You can also go to ASHRAE's weather data, climate data website that also has information, although it's a lot more information than what you need for Manual J, and can be a little bit difficult to suss out what you need to use from that information. So I do recommend that Farm Energy Extension link there as a good resource. Just some quick notes on terms. Dry bulb, that's your actual air temperature is measured by a thermostat. A wet bulb is your lowest air temperature achievable from evaporation. And grains is a unit of measure of absolute humidity, where 1 pound of water is about 7,000 grains. When you're looking at those design grains, 90% of the time, you're going to be selecting that 50% relative humidity indoors as your design condition. And that correlates to about a 60 to 63 degree wet bulb temperature for your indoor design conditions. The reason that's important is when you go beyond Manual J to the Manual S to sizing your equipment, that has an impact on, as you're going through your manufacturer's data, it has an impact on what the actual output capacity of your system is, depending on what those returning relative humidity to the unit is. The other conditions are for if you have specific situations happening. You would use the higher relative humidity if you know you're going to have really high loads in the building from occupants or cooking for whatever reason. And the drier conditions usually is tied to a drier climate that's going to keep that interior humidity lower for any reason. But in general, for most conditions, you're going to be using that 50% relative humidity condition. And then as far as your interior loads for the second step, you're gathering your peak internal equipment and occupant loads. as we look at the abridged version of the speed sheet, is just a drop down with 3 options for your interior loads. Generally accounts for your largest equipment, the refrigerator, a television, and I believe a stove cooktop. But there are calculations for the full manual J that you can input things like ceiling fans, lighting loads, all that kind of information. And so again, this is very important for your design temperatures inside the building, because that temperature difference across the envelope determines what your peak loads are. We have seen in some manual J's where the winter design temperature and the summer design temperature are reversed. And they do that. In some cases, that's done to get the outputs to match up with rule of thumb calculations. So they think they may have entered something wrong because the output isn't what they expected. It's much smaller. But in this instance, very important that your winter design temperature is at 70 degrees Fahrenheit, and that your summer design is at 75 Fahrenheit at 50% relative humidity, unless you have specific factors that change those design conditions. And then those must be documented for compliance. And again, that summer design condition of 50% relative humidity should be remembered, as it's very important for your manual S calculation. That corresponds to a 62-degree interior dew point. The 30% relative humidity that's listed there for the winter design is a dew point of about 55 degrees. And that's a design condition where the relative humidity isn't expected to produce condensation on windows and cold surfaces within the building. Although for the purposes of the load calculations, the humidity isn't really factored in for winter design, as we're not removing that humidity from the air. And then step 3, this is kind of that most detailed portion of the process, where you're putting in all your insulation R values, the surface areas those R values are applied to, your solar heat gain coefficients and U factors for windows and skylight assemblies, your air infiltration rates, any duct leakage rates. So you're going to need a lot of information to complete this step. And this is kind of that most time intensive portion, especially as you're going back through and making sure you've entered that all correctly. So just a quick section looking at the envelope portions of the building. Just a quick overview of the inputs that are on the speed sheet. You'll see similar inputs for full load calculation software. Above grade walls can be either framed or massed walls between indoor space and outdoor conditions. Partition walls are between indoor conditions and unconditioned spaces like a garage, knee walls between interior and an attic. So it's important to know that that above grade wall section is specifically between interior and exterior conditions, and partition walls is interior and some semi-conditioned or unconditioned space condition. Below grade walls then are going to be any walls that are greater than 2 foot below grade. So that is an important note there. It has to be more than 2 foot below grade to qualify as below grade wall for the speed sheet entry for manual J entry. Ceilings can be below the attic, below the roof deck with exposed beams, or below a deck with sandwich beams. A partition ceiling, again, is any ceiling under an unconditioned space that is encapsulated, like an insulated attic space, where that attic isn't necessarily conditioned, but it is fully enclosed in foam. It's partially conditioned by the house. Again, to note here, it's interesting that they include that partition there for ceilings for the abridged edition of the speed sheet, because you're not allowed to account for insulated attics in the abridged edition. There are some exceptions to those rules in the abridged edition. If you go through the checklist, they have some call outs that you can do some specific adjustments to calculations and still use the abridged edition speed sheet. And that might be why that partition is included there. And then getting on the floors, passive floors, again, are floors without radiant heating. Otherwise, it's an active floor. Partition floors, again, that's a floor between a semi-conditioned space. If you've got an enclosed crawl space, but it's not fully conditioned. If you've got a partition between any kind of fully conditioned spaces, then you're not going to include those in the calculation, because there's no heat transfer across that surface. Very commonplace for exposed floors is bay windows, they'll have a small floor section or overhangs of the building. Partition floors is usually used for bonus rooms above a garage space. And then slabs are floors that are less than 2 foot below grade of the soil surface. So just an example of the kind of lookup tables that Manual J is using. If you're doing the abridged edition, you're going to be using these tables yourself. You'll have to have access to the Manual J and look these up to enter them into the calculator. But this is an example table for a 2x4 wall with various levels of insulation. Just an example of that's highlighted here is looking up an R13 wall with the R5 insulation board and vinyl siding. In this case, something to note is if you remove that continuous insulation on the outside, the choice between vinyl siding or brick siding starts to have more of an impact. So you can see construction assembly 12A at the top of the table there, the brick and siding actually have different U values associated with them because of the difference between the insulating value of a brick versus vinyl siding. But as you add continuous insulation, that starts to have less of an impact on the wall. And so by the time you get down to the R5 section that's listed here, brick or vinyl siding has the same U factor associated with them. But you'll find similar tables for looking up windows as well. For the abridged edition, you're kind of limited to using default window assemblies. They do have calculations that you can enter NFRC rated windows into the abridged edition calculator, but you do have to do a separate calculation outside the calculator to do that. But something that's important to be aware of is when you're looking up window information, you need to include things like bug screens on the window, as those add a slight amount of shading, the position of any interior shades or blinds, if you're expecting a portion of that window to be covered, because that does, again, remove how much solar heat comes through the window. And you also have to account for any overhangs that are shading those windows on the outside of the building. So even minor things like the bug screen are accounted for in this load calculation. It's important to be aware of those so they don't get accidentally left off. When you get through your assembly entries for above, below grade floors and all that information, then you start entering information about air leakage in the building and air leakage in the ductwork. So for the Manual J, it's concerned with above grade conditioned volume when you're entering your air leakage rates. So if you have like a partial basement where part of it's above grade, part of it's below grade, the below grade portion is assumed not to have any infiltration or exfiltration because the soil is going to block that kind of air movement. So only the above grade portion and above grade volume of the building is considered in those infiltration calculations. For the abridged edition, you've got a drop down of selections from loose to tight construction types. For any new construction homes where you have to meet these interior blower door tests, you're going to be using the tight selection most of the time. If you've got a leaky house that maybe just barely meets that blower door, you might use the semi-tight leakage value. But really the only time you're using any of the values less than that is if you're doing a Manual J calculation for an existing older home, kind of before we had to start using blower door tests for home construction. So most homes now are going to be using that tight or semi-tight, even if you're doing an existing home calculation. For duct losses and gains, again, the abridged edition has a very limited selection of duct construction classes. A couple of examples are listed here. You either have a radial system where you've got kind of that central unit with ductwork branching out from it in all directions, or a flexible trunk and branch system. And then there's two versions of that, one where the return is right by the unit or one where the return is ducted a little bit of distance away. For the full Manual J, you'll need to be able to calculate or estimate the initial surface area of your ductwork because that's important for the ductwork calculation for loads. There are 28 tables of different duct layouts in the Manual J, depending on whether they're in the attic, whether they're in a crawl space, what kind of duct layout there is, whether the return is with the unit or ducted away from the unit. And each of them has kind of a 4-step process. You've got a basic baseline heat loss and gain based on just the surface area of the ductwork. Below that will be a row of tables that has multipliers for the insulation level that's applied to that ductwork. After that, you'll have a list of tables that has multipliers for duct leakage rate, so that you can account for, if you've got ducted returns, you're going to have air drawn into there that's going to have its own temperature and its own latent gains as far as humidity. And then for supply ductwork, you've got direct temperature loss of conditioned air into the unconditioned space. And then you'll have finally adjusted multipliers for if your surface area of your actual ductwork doesn't line up with the surface area that's estimated by the initial table. There's a multiplier factor table that adjusts for those leakage areas to give you the heat transfer multipliers that you need to do the manual J calculation. So this is probably the most complex step and probably the most confusing portion. But if you take it on a step-by-step basis and go through these as those kind of 4 sections, it can make it a little bit easier to track. If you're doing software, it does most of this for you. The only main thing that you have to be aware of is calculating the surface areas of your ductwork, and it'll kind of do the rest of the analysis for you. But that is kind of that detailed step process that that software is taking in the background. So we do have another poll question here before we move on to some common mistakes. So our first question are, what are the 3 main categories of information that go into the manual J? Your outdoor temperature extremes, the desired indoor comfort condition and informative information, your average outdoor temperatures for cooling and heating design. Actually, I can't see the entirety of what's written there. The acceptable indoor temperature and something else. I wish I could see the entirety of those responses. Ductwork size, whether the space is above or below grade, and the climate. Question number 2 is, what best describes the manual J calculation method? Simple equations for calculating heat transfer through the envelope, lookup tables of pre-calculated factors according to construction type, materials, components, or a complex hour-by-hour load calculation. Let that run for a couple of minutes here. I haven't seen any questions come into the Q&A. Looks like Jane answered one.
Just that we are recording this and we will share the recording on our website.
Okay.
And then here's another question that we just had come in, Sean. How long might I anticipate this manual J calculation taking? That was a lot of stuff we just listed.
So I did one for my apartment here, which is about 850 square feet. And it took me, I'd say about 2.5 hours to gather all the information and enter it into the speed sheet software. I also entered it into an online software, and that took a little bit less time as I wasn't doing the lookups and things like that. That took me about 1.5 hours.
And one of the nice things about that speed sheet is you can download it, and if you had a whole bunch of apartments like Sean's, you could just change it a little bit.
Mm-hmm. Yeah, once you've got an initial manual J set up, especially if you're a builder that does model homes, you can use that same model, and all you have to adjust for is the location and orientation of the home and any minor adjustments you might have for options that are included in the home. So, all right, let's share our results here. So the correct answer should have been the second option here. You're looking at you're not looking at temperature extremes on the outdoor.
Well, we're looking at those, the temperature extremes in the sense that we're looking at worst case scenario in the summer and worst case scenario in the winter. So that may have been a little bit tricky though, because we are looking at what's the average temperature inside, what's that design temperature inside. But for outdoors, we're not designing for the average day, we're designing for worst case, because we don't want those the equipment to not be able to maintain comfort.
You're correct. It is the first answer is the correct answer there.
Yeah, we may have been a little bit tricky there though.
And then for the second one, a good description of the manual J, it is a set of lookup tables for pre-calculated heat transfer factors based on your material components that you're pulling together to get those peak load calculations. So yeah, well done. As far as we did have another question about proper assembly codes, those are included in the tables. If I go back real quickly to the slide I had on the above grade wall lookup table here. Oop, I think I went past it. So you can see the assembly construction numbers are listed here on the left side of the table, and there's a final group number code that gets included with that on the right side. So those are included in the lookup tables for your construction assemblies.
We've got one more question in the chat from Greg. Can this be used for just cooling, such as when adding mini split units to an existing boiler? And you could, but you might as like if you're designing those mini splits just for cooling, you'll still go through the same process. But you need not design them to provide the full heating load if they're just going to be used for cooling and redundant for heating.
So we'll answer a couple more questions that have come in as we get towards the end, but we want to try to be cognizant of people's time here, so we'll go through the rest of the presentation.
But please do add questions to the Q&A, and we'll try to get to them at the end.
Yeah, we'll definitely get to them before we wrap up here. So just some common errors that we see when entering Manual J information. And sometimes these are manipulations because people get a result that they think is too small because they're familiar with these rule of thumb estimates for cooling, like 500 square foot per ton, 600 square foot per ton, something like that. And so they get this Manual J result and they figure they've done something wrong. And so they start tweaking it to get the result they expect. And what we're showing here is an example of how much a difference some simple changes can make. So here is an example from some Manual J calculations done in the Chicago area where they manipulated the indoor and outdoor design temperatures. So they flipped the summer and winter design condition temperatures for the interior. And instead of using the design outdoor conditions of 89 Fahrenheit for cooling and 97 Fahrenheit for heating, 89 for cooling and -2 for heating, they went with temperature extremes in the Chicago area of 97 degrees and 11 Fahrenheit. And that resulted in about a ton of oversizing in the model, just from changing around some of the temperatures. And so that's something that we've seen a couple of times with Manual J projects, particularly reversing the heating and cooling design interior temperatures. And as I noted earlier in the program, when entering window information, even minor things can have an impact on the window cooling loads coming into the building. So here again was the same models for the Chicago area, but what they did was they left off some of the window treatments. In this particular case, they didn't account for the bug screens, and they left off the overhangs for the roof eaves. Most buildings have some amount of overhang of the roof over windows. It might be a foot, might be a couple feet, depends on what they were trying to do, if they're trying to get some passive qualities to the house or not. But even those minor amounts of shading have an impact on the loading of the Manual J calculation. And here that resulted in about a half a ton of additional cooling load for the building, just leaving off those overhangs and the bug screens and blind positions. So very important to get those entered correctly. Getting the areas right, kind of probably the most common error that we have seen, happens a lot with some other programs as well, like ResCheck and ComCheck. If you're entering a slab on grade floor, sometimes people put in the area of the floor instead of the perimeter of that slab. The perimeter is the entry data point that you need. But it's very important to, if you're checking through the Manual J, to look at the components. Most of the software will have outputs by component construction. Look at the ones that have the largest associated energy ratios to them. and check those. So where you've got low R values, particularly windows, making sure that the area is entered correctly for those. We have seen some software has manipulated the window area to increase the loads just to get closer to those rule of thumb estimates that they believe they should be at. Window orientation can also have a big impact. If you've got south facing windows that you're trying to take advantage of solar heat gains, those are going to have a negative impact at nighttime on your heat loss of the building. So very important to check those, make sure those are entered properly. We're showing here is just a comparison from window entry into a manual J for different assemblies. The first assembly in the darker green there is an R23 wall with an R3 window, kind of your typical performance for a window at a 10% window to wall ratio. And the light green is an R17 wall with an R7, like really high performance triple pane window, probably has some argon fill or another inert gas in it. So those are going to be really high performance windows. And you can see that at lower window ratios, it's not going to have a huge impact on the difference between those two calculations. But as you increase that window to wall ratio up to that 35%, you can see that R3 window has a big detrimental impact on the overall insulation value of the wall. So just calling out here that it's very important to make sure that those insulating areas are correct, particularly where you've got low R value surface areas in the building. Duct areas also have a significant impact. Again, particularly if you got ductwork in an attic where you can have really high temperature differences between your supply air in a ductwork might be 55 degrees while the attic is 100 plus degrees. And that ductwork only has R6 insulation around it unless it's fully buried under your attic floor insulation. And so that can have a big impact on the loads experienced by the HVAC system too. Duct leakage is another area. What we're looking at here, this was some manual J calculations from the Atlanta, Georgia area. But they manipulated what kind of the location of the ductwork and how much leakage it was having. And in both cases, changing the attic leakage rate from 15% down to 5%, and the crawl space from 15% to 5%. In both those instances, on the cooling side, it was just under about a ton of cooling, and on the heating side, it was about 8,000 BTUs of impact just from that 10% leakage rate difference. So again, important to make sure that those loads are properly entered into the manual J. It's also important to note that when you're doing a manual J, it will still oversize your equipment by about 10 to 15%. The manual J process isn't an exact calculation software like you might have with an hourly program like eQuest or RemRate, something like that. It's doing a peak load calculation with, in general, basic information about your heat transfer rates. But it's important to also note that if you're trying to hit these rule of thumb estimates of about 500 square foot per ton, which is shown on the chart here where that little thumb is, for most homes, this was an Energy Vanguard study, they showed that none of them were at that level. And on average, you're closer to 1,400 to 1,500 square foot per ton. So a lot of the times when we're looking at manual J's, errors and entry and things are put into that manual J to get closer to that rule of thumb, because that's where the contractor is comfortable with the equipment, and then they feel like they've entered that information correctly, and they figure there has to be something wrong if it's not near that rule of thumb. But those rule of thumbs are outdated now and really shouldn't be used anymore. So put in accurate information in that manual J, and you'll get a much better result when you actually install that equipment in the building. So we do have another poll here we'll launch into before I pass it back to Jane to wrap up the last couple sections. So our first question is, window screens are a factor in the manual J calculation? No, they're not. Or because they increase shading on the windows, reducing cooling. because the increased time occupants will open the windows, and that has an impact on infiltration, or they're included just to confuse designers and make the calculation complicated. Question number 2, rules of thumb for HVAC sizing: grossly oversized equipment almost all the time are a safe bet. You don't want comfort complaints on a cold day. Can lead to problems based on wasted energy due to short cycling of equipment and inadequate dehumidification, or both A and C. And while that poll's going, we've got a couple more questions that have come in. For a typical basement foundation, the wall is partially above and partially below grade. Do you need to break that up in the calculation? I would have to look into that and get back to you. I don't believe so. I believe that the entire wall assembly is entered as one or the other. But if you've got a, say like you've got a foundation wall that's below grade, and then you've got a separate wall assembly, like you've got a framed wall sitting on top of that for the above grade portion, those you would separate out. But I'll look into that and verify, because I'm not entirely sure. We'll have to get back to you on that one.
Yeah, that's what I thought too, but I'll wait on you. And Brian says, how do we address the village requesting a manual J with a job with existing equipment installed? And that's probably an energy code question in terms of the chapter on existing buildings. So, I'd say, if the equipment is existing and it's not being modified, the energy code will not apply. And therefore that manual J requirement.
Yeah, if you've got existing equipment and you're not changing that existing equipment, then you don't need to do a manual J for it. If you do change out that equipment, you do have to do a manual J to verify its proper sizing. Okay, well, looks like we got all our poll answers in. So it looks like most people got the first question correct. Those screens do increase shading on the windows and reduce heating load, so they are important to include in that manual J. And then for the last one, both A and C are correct answers. Rules of thumb: grossly oversized equipment in most cases, and they can lead to problems with wasted energy and inadequate dehumidification. Well done.
Great. Well, thanks, John. Yeah, and I'll speak a little bit about, we've talked about how these calculations proceed and how you would do it by hand to understand how these calculations work, but I'll talk a little bit about software options, as that's how most folks will perform these calculations. And as we, actually, there's one question that came in the chat, which is relevant here. Can we use our BIM model calculations to size equipment? And if we turn to, again, to the IECC, the requirement is to use the manual J or an approved source. So if you're code official, because approved is defined as acceptable to the code official. So if your BIM calculation is acceptable to the code official, that will be acceptable. But so we're going to talk about manual J approved softwares real quick here. If I can. So here again is that list of available software. And you can find this full list on the ACCA website. So these are going to be directly approved by IECC. And we'll talk a little bit about this last one on the list here, this Cool Calc, which is not intended to be an endorsement, just because it's easy to access, it's free to use. You will have to purchase it to print your reports for your code official, but it's free to use. So if you're interested in trying out a manual J, trying out software, that's a good one to check out. So we'll talk a bit about it. So here's a few example screens. So what would it be like to fill out this manual J in a software application rather than in that simplified speed sheet? And so there's going to be a lot of similarities in the sense that we need to pay careful attention to our input values and units. So when Sean spoke about areas, it's really critical that we're inputting a value that means the same thing as the value that's expected. So if we're inputting a perimeter, rather than an area, that's going to mess up our calculation. And the example shown here is for infiltration for your blower door test. Some programs might want air changes per hour, or they're going to be looking for the equivalent leakage area. So make sure that you input the correct answer, because otherwise it's going to, of course, throw off your your result. But you can see that this is a little bit more user-friendly approach, as we're going to input our dwelling information, infiltration, construction profile. This is a little bit easier maybe to navigate and to see than that Excel sheet. So here's another example of where you were going to have to be careful with how we input and some of the limitations of the software. So for example, with this school calc, we have a listing of, we don't actually physically enter the R value of insulation. It just gives us certain options. So, we may be looking at, we've got R40, but the closest that we're able to do is in R38. So we may have some limitations there, but just enter the data as close as possible to the actual conditions, and understand that there are some base assumptions and limitations in the software that are going to be built in. And be aware of what those limitations are and how they affect your calculation. So in this case, for Cool Calc, they list some of the known issues that they have. So be aware of them. Just hopefully it will help resolve some frustration, but also as you're choosing software, you might want to look for one that is not likely going to impede with the kind of designs that you're working with. So most of these software providers will keep a record of the limitations and known issues, but all of the software that's listed on the ACCA website is approved. So it should be acceptable to your code official. So it'll be mostly about usability and the function of that software to do these calculations. And again, as we mentioned, with the limitations of that simplified calculation, unless you're doing like just replacements of units on similar houses, you're probably going to want to invest in some kind of software if you're doing these calculations on a regular basis. So be aware of what software is out there, and how it's used is going to be a good investment. And then there's a few steps beyond the manual J. So we want to talk about what do you do once you've calculated the heating and cooling loads for the equipment. What are some of the next steps that get you to a full HVAC design in your home? So the next two steps are the manual S and the manual D, which are needed to complete the residential load analysis and properly size the actual equipment. The manual S adjusts the equipment from manufacturer default test conditions to the air conditions assumed in your load calculation. And so this one, it's kind of a hard or like a complex concept to grasp, but it's actually quite simple. Your manufacturer of a furnace or an air conditioner tests it in a laboratory at default conditions, and they're not exactly the conditions that are going to be present in the home you're designing. So we just need to adjust those outputs to account for the actual conditions in the actual home. So how will that equipment perform in the actual home? And then we compare that number, what's the actual output in the actual conditions? We compare that to our load that we determined in manual J. So manual S is an important check to make sure that the equipment is actually going to be the proper size. And manual S also includes a little bit of a range of, how much can we oversize or undersize? What is appropriate? Because of course, we're not going to make a custom piece of equipment for each home that we design. So we're going to pick a stock piece of equipment that fits as closely as possible or as closely as necessary. And then manual D sizes the ductwork. So this is where we talked about how if you're designing ductwork, you're probably going to want to do a room by room. Manual J, and that's because you're going to be able to look at the loads from manual J room by room to define how much air needs to go to those different rooms based on their loads. So those are the three ACCA manuals, which together are able to design the full HVA system. But beyond the ACCA manuals, there are hourly energy simulation programs, such as the DOE's Energy Plus for commercial buildings, that can analyze annual loads for residential. So this could be something that you will know would enable us to look in some more detail at how these systems are going to perform on a regular day, not just what do we need to do for those peak loads, which is really critical to sizing equipment to maintain comfort on those extremes. But we also want equipment to perform well on an average day. So if we do this kind of analysis, we may be able to better design a system that, for instance, has a high fire and a low fire to ensure that it's able to perform efficiently on the most common design condition, not just those extreme days. Some other examples are energy gauge, REM rate, BOPT, and others that provide annual energy consumption. So this can be used for net zero planning, energy code, ERI calculations, and load sizing. So they usually don't include duct sizing, but these can help, as a more detailed manual J type of calculation to learn a little bit more about how much energy the home's going to use with various types of equipment. So, if we want to, design the most efficient, not just a code compliant house, we may want to go beyond these ACA manuals to do more to analyze how these HVA systems will work in our homes. So, at CDAC, we always say that the bare minimum energy code compliance is kind of like a D-. So these are what we might like to do to go beyond that. So here's a website, which I'll stick in the chat if you want to go beyond that. And I think we have some questions that we'd like to get to. Let me see. Oh, what about, and yeah, thanks, John. We got a poll. Yeah, we have a poll we'd like to know a little bit about you. How often do you use the manual J? And are there other resources that you're interested in learning about? So as we're answering some of these questions in the Q&A, please fill this out. We'd like to know what you'd like to learn about in future webinars. And questions, we have one question that has come in about vaulted ceilings.
Yeah, so if you've got a home that has kind of a standard attic, but you've got a dormer with a vaulted ceiling extended off of that, those would be entered as two separate assemblies in the manual J. You would have the standard attic and any, the ceiling partition between that standard attic, and then the dormer would be a separate ceiling entry in the manual J. So you would enter both of those, and it would be considered a vaulted ceiling entry. Yep. And
then a second floor addition. You're probably going to be replacing or at least adding HVAC equipment because you're adding square footage to the home. So the IECC requires that in renovations that any new areas, so the whole second floor addition, but also the new mechanical equipment will have to comply with energy code. So you will have to do a manual J for the new equipment. If you're not modifying ductwork, so you may be adding a little bit to the ductwork, but not modifying the whole system, there's specific provisions for when that ductwork needs to be brought up to code. So check the what is it, R405, the section of the IECC for renovations for details, or reach out to CDAC and we'll be happy to dive into the details with you about your renovation.
But as far as the manual J goes, if you're adding an addition to a building, you're still going to model the whole building. Try not to confuse the manual J where you're sizing the equipment with code compliance, which those are kind of two separate topics.
Unless, for instance, you had a mini split for that addition and it wasn't serving the rest of the house.
Yeah, if you were adding on a space that had its own piece of equipment, you could model that space individually.
And then Jennifer says, if an addition is proposed for use with existing equipment and modified extended ductwork, where is the requirement for manual J? So that's kind of, it's a similar question. And that the requirement to do a manual J is required. And there's no exception for that in the modification of existing buildings. So that requirement remains. But reach out to us. We'd be happy to cite that over email for your convenience.
Yep. It goes back to if your existing equipment isn't being changed, you don't need to do a sizing calculation. If you change the existing equipment, then you have to do a manual J to properly size it. Let's see. I think we've got, let's share our poll results here real quick. Touch on the last couple questions. So we had a nice mix of people joining us today, mainly architects and engineers and code officials, but a couple contractors and others attended. Most people are not doing the manual J, which is interesting with the code requirements for it. I'm wondering how many people are doing other software applications like RemRate or building modeling and getting compliance through those methods instead of using the manual J. But then where would we like more information? Manual D, manual S, we can touch on those in the future for sure. Efficiency of equipment, calculating savings. Yeah, we've got a nice mix of interest there. So, all right, great. Nope, I forgot to share those. I ended the poll and wasn't sharing them with everyone.
Yeah.
My apologies. All right, so we had a couple more questions come in. We'll answer those before we wrap up here. We had a question come in. An attic was converted to an addition with the vaulted ceiling completely.
I think this is relating to the previous question.
Okay. So yeah, again, for a manual J, you would enter in the full building for the sizing of that for manual J's purposes. For code compliance purposes, it kind of depends what was done there, but the converted portion of the building would have to be considered for the code compliance portions. The base floors of the building would not be included in that code compliance analysis. And then when will the 2021 code for IECC go into effect? So they're in those discussions now, going back and forth about amendments to that code for Illinois. We expect sometime in, I believe, the spring or summer of 2022 is when those should be released. But we will release that on our website and through our newsletter as soon as we know an exact date for when the 2021 IECC will go into effect.
And there will be ICC credit for this training. We'll reach out to everyone who participated by email after the program. Thanks everyone for joining us today. And thanks for all the excellent questions.
We have one more come in here I'll touch on. I do block loads for certain cities, but not all. Why? I'm not sure. Mainly that block load calculation is if you're not going to follow up with a manual D calculation. So that may apply in buildings where you're using ductless mini splits, or I mean the manual D duct sizing is, let me check real quick in the code here, but I'm not sure that that's specified that you have to do manual D duct sizing yet. And so that may be why you can get away with doing a block load calculation for equipment sizing.
Ryan mentions it's required by the IRC for the residential code. You need to do that manual D. So if for some reason that doesn't apply to the project, maybe that wouldn't be necessary, even though the energy code applies. But it's always a good idea because you want to get, make sure that people are comfortable in their rooms. For swapping out equipment, we had a question. These are swap outs. For swapping out equipment, you're probably not changing the ductwork. So, if you're not changing the ductwork, you're not required to bring it into compliance. So no calculation will be required.
Yep. So that's why you can do the block load for those. If you're just swapping out the equipment, the ductwork is staying the same. The assumption is that ductwork was adequately sized. Right or wrong, that is the assumption that's put into that. So that's why you're allowed to do the block load for a swap out. Yep. Okay, thank you all for attending today. We hope you found this informative, and you'll come back for our future webinars.
Yeah.
Have a wonderful afternoon.
We'll be in touch about ICC credits and AIA.
Yep.
Thanks all.
Thank you.